Good day everyone. Thank you for joining today's project status report for Learn AI. My name is Julie Tattao, together with Cheryl Punsalan and Rhea Molod. We'll walk you through our progress across three phases of the project. First is the discovery, second is the design, and our current sprint 1. By the end of this presentation, you'll know exactly what's been completed, what's still in progress, and what decisions or inputs we need from this group today. So here's how we organize today's report. I'll start with the discovery phase with the three completed milestones covering requirements validation, our ethics review board submission, and our dataset curation plan. Cheryl and Rhea will then walk through the design phase, covering system architecture, our Supabase schema, and the API specification were all completed. Finally, Rhea will close with an update on Sprint 1, where we're actively building the authentication and account management module. After each milestone, we'll flag specific points we'd like the group's input on, and we'll end with a summary and open discussion. One more thing before we start. For system architecture, database schema, API specification, and authentication and account management, we've added a deep dive slide right after the milestone summary. Those go beyond the headline deliverable into the technical detail. Diagrams, endpoint contracts, RLS enforcement, and our current blocker. So we can have a substantive technical conversation, not just a status readout. So let's begin with the discovery phase. This phase was about making sure we were building the right thing, the right way, before writing a single line of production code. Our first milestone was requirements validation. This is now complete. We have an approved business requirements document version 1 with signed off business goals, metrics, and a full list of business requirements. A few numbers were worth highlighting. We're targeting at least 90% neural network classification accuracy, 20% reduction in repeated error types, and a 30% reduction in instructor review time. What I'd like to discuss with the group, let's walk through these validated goals together. I'd like to confirm formally that our stakeholders, the university, and the project manager have signed off. For our ethics review, board submission is also complete. We secure ERB approval, and our data privacy documentation is aligned with the Philippine Data Privacy Act of RA 10173. This certification affirms that our data collection, analysis, and interpretation are original and of high quality, that we followed valid and reliable ethical guidelines and research protocols, and it grants university the right to publish the work. We're treating this signed certification as our ethics review record for this milestone. For discussion, I want to confirm with the group that this certification satisfies the university's ERB documentation requirement and formally closes out the dependency. I'd also like to propose a timeline for our data privacy audit, which still needs to be completed before pilot launch. So on our third discovery milestone is the dataset curation plan. The plan itself, covering sourcing and labeling methodology, targeting over 2,000 labeled Java samples, is completed. Rhea Molot owns this work stream technically. However, I want to flag something important here. The actual labeling work is still ongoing. This dependency directly blocks two of our business requirements, 003, error classification, and business requirements 010, our 90% accuracy validation. So a delay here has really downstream impact. For discussion, I'd like Rhea to confirm our current labeled sample count against the 2,000 plus target, the remaining timeline to finish, and whether the team needs additional support or resources to keep this on track ahead of the accuracy validation milestone.
Boom. Thank you, Julie. I'll now hand it over. My name is Cheryl Punsalan, and together with Rhea, we'll cover the design phase, where we translated our validated requirements into a concrete technical blueprint. Our system architecture is finalized. We're building a Supabase for authentication, database, storage, and real-time features, paired with dedicated cloud VM running our Java neural network microservice. All client-server communication runs over HTTPS and TLS 1.2 or higher. For discussion, I'd like to walk the team through our hosting and infrastructure decisions, specifically how this architecture is designed to support 50 to 100 concurrent users while keeping feedback under 5 seconds. Let's go one level deeper on the architecture, because this diagram is really the backbone of everything else we'll show today. At the center sits our cloud-based neural network programming platform. On the left, the cognitive tutoring system handles real-time error detection, stepwise hints, personalized guidance, and adaptive feedback. That's the layer students actually feel when they submit code. On the right, the adaptive hypermedia learning model manages content sequencing, personalized learning paths, difficulty adjustment, and learner centric recommendations so that the platform doesn't just flag errors. Underneath both of those sits the data driven learning analytics framework, which handles performance monitoring, predictive analytics, coding patterns recognition, and data driven interventions. This is what feeds our instructor dashboards. All three of these pieces run on top of a shared cloud computing infrastructure built for scalability, real time processing, and multi user access. In practical terms, the means Supabase carries authentication. Our Postgres database, file storage, and real-time channels as one managed service. So, we're not standing up and maintaining our own authentication servers or database clusters. The Java Neural Network microservice, by contrast, runs on its own dedicated cloud VM, deliberately separated from Supabase. So, a spike in classification request never competes with the database for resources. Every hop between the client, Supabase, and the VM is encrypted end to end over HTTPS with TLS 1.2 or higher. For discussion, I want to walk the group through why we isolated the end-to-end service on its own VM rather than collocating it, and get feedback on whether the single VM is sufficient to launch with, or whether we should provision our standby instance ahead of the September 16 pilot. I'd also like to confirm the group is comfortable with how connection pooling and stateless API calls let us scale to 50 to 100 concurrent users without a redesign, and how the asynchronous submission pipeline keeps our feedback loop under 5 seconds. Our database schema is also complete, built on PostgreSQL 15, covering users, roles, code submissions, classifications, feedback, and analytics tables, with row level security policies designed in from the start. I'd like to walk through the schema with the team, confirm our approach to enforcing role-based access control through RLS, and review our backup strategy, automated daily backups, and our data recovery plan. Zooming into the schema itself, this input process output model shows how data actually moves through our six core tables. On the input side, we're capturing two streams: student engagement, meaning login frequency, module access, and code submissions, and instructor intervention, meaning feedback, remediation, and instructional support they provide. Code streams feed the process stage. Code submission, real-time code analysis, error detection across syntax, logical, and structural errors, neural networks pattern recognition, adaptive feedback generation, time series analytics, and performance monitoring. The process stage is really the engine room of the whole platform, and it's what writes into our classifications, feedback, and learning analytics tables. The output stage is what everyone actually cares about. improve programming proficiency, reduce coding errors, increase engagement, and learning analytics insights for instructors. And importantly, those outputs feedback into the input stage, which is why you see the feedback loop arrow at the bottom of the diagram. Outputs inform inputs, so the system keeps adapting over time. On the security side, our roles table isn't just a label. Row level security policies enforce it directly in Postgres. So a student query physically cannot return another student's submission or feedback rows. And an instructor's analytics queries are scoped to their assigned modules only. The protection holds even if someone found a way around our application layer. For discussion, I'd like to walk through the six tables and their foreign keys relationships in more detail. Confirm the group is aligned on our RLS enforcement approach and get input on our backup strategy. We have automated daily backups configured, and I want to propose a target recovery time objective ahead of pilot launch.
Thank you, Miss Punzalan. And I am Miss Mollet, and I'll cover our third design milestone, which is the API specification. This will gives you the complete and it covers the three areas, which is authentication endpoints, the functional requirements 001 to 005, code submission and feedback endpoints, which is the functional requirements 007 to 010, and our neural network classification endpoints, which is the functional requirement 011 to 015. What I like feedback on is that let's review the endpoint contracts together, particularly how we're securing the internal API key used by the Java neural network microservice and how this design setups for future learning management system integration under the business requirement 011. So for our API specification, I'd like to connect it with our use case diagram because I think it makes the endpoint groupings much clearer. On the diagram, you can see two actors, which is the student and the instructor, each with their own set of use cases, and a third actor, which is the neural network, that several of those use cases ultimately use. Starting with the authentication, the function requirements 001 to 005, this covers the register account and login in use cases for both roles, edit profiles, and manage settings. Under the hood that's registration, supervised authentication login issuing a JSON Web Token, role-based redirect to the right dashboard, profile editing, and structured error messaging when something goes wrong. Next, the submission and the feedback, which we can see in our file, the functional requirement 007 to 010. On the student side, that's the start exercise, submit answers, view errors, and give feedback. While on the other hand, on the instructor, it is the course management, access student performance, and view learning analytics. These endpoints handles code submission intake, real-time error detection, adaptive feedback delivery, and progress tracking. Finally, the neural network classification endpoints, which we can see in our document, the functional requirement 011 to 015 are what the diagram labels. Process code submissions, analyze errors, detect coding patterns, and generate automatic feedback, all of which route through the neural network actor. On the instructor side, monitor coding behavior and identify learning patterns pulled from that same classification layer. One thing worth calling out, the web application authenticates to the Java neural network microservice using an internal API key that never leaves our server-side environment. So those classification calls can be spoofed or called directly from outside our system. So I'd like to discuss the review of the endpoint contracts in more detail. confirm the group is comfortable with how we're sorting and rotating that internal API key and talk through how this endpoint structures is designed to support future learning management system integration under the business requirement 011. Since course management and access student performance are the use cases most likely to be touched by the integration. So let's discuss our sprint one. With the design round up, we'll move into the active development. I'll walk you through where we stand. So our sprint one, which is about authentication and account management, which is currently ongoing. Our current sprint focuses on authentication and account management, registration, super-based authentication login using the JSON Web Token and Bicrypt role-based dashboard redirects, profile editing, and error messaging, which is under the functional requirements 001 to 005, which are all in progress and functional in early form. So let me run you through the live registration and login process of our system. So let's first register a student account. Choose the role, which is student or an instructor. First is student. Upon writing all the deliverables, which is the name, the student ID, email, and the password, we need to confirm the terms and conditions of our system so that you can create your own. So this is the dashboard that the student will see upon logging. Log out and extract. So upon filling in all the deliverables, which is the getting the role, the full name, the department, password, put down, and agreeing to our terms and conditions, we can create our. So for the instructor, this is the dashboard. We'll see. If ever the student or the instructor already have an account, just write, we can just type mail, enter password. Upon logging in, the system will automatically go to the instructor dashboard if he or she was registered as an instructor or a student tab. So let's log in as student. So this is the student. As you can see, we don't need to choose the role. The system will automatically go to the student or instructor dashboard if he or she was registered as a student and instructor. So that is the run through for our login and registration process of our system. So let me go deeper on our sprint one. So the registration, which is capturing the name, the email, password, and role, and symbol-based authentication login using the JWT tokens with barcode password, hashing, or both functional end-to-end in our current build. If time allows, I'd like to demo that flow live for the group right now. So role-based dashboard redirect, profile editing, and structured error messaging under the functional requirement 001 to 005 are implemented in early form and are being actively tested in this sprint. They work, but we're still hardening edge cases like duplicate email registration and expired sessions. Our current blocker is full production super-based provisioning. Our development and staging environments are functional, but we can't finalize production environment variables or lock in our role level security policies until the production super-based project itself is live. That's the single dependency holding this milestone at ongoing rather than completed. Looking at our delivery timeline, discovery run from June 22 to June 28, and it is completed. Design run from January 29 to July 12 and is complete. And Sprint 1 began on July 13 and it's currently ongoing. Targeting July 26 for this authentication work that give us a clear runway into Sprint 2 once this was closed out. So I'd like to give the group a live progress update, walk through the Suba-based provisioning blocker in more detail, demo the registration and logging flow, and propose a firm completion timeline. And I'd like the group's help escalating the provisioning dependency since it's now the critical path for this milestone. So to give you the overall summary, here's our project manager.
So, to summarize where we are, six of our seven milestones are complete, spanning the entire discovery and design phases. Only one milestone, the authentication and account management in Sprint 1, is remain ongoing. Before we open the floor, four items needed the group's attention. First is the dataset finalization risk and its impact on our accuracy validation milestone. Second, the Sprint 1 progress and blockers on the authentication module. Third, the SUPA-based provisioning, which is a blocking dependency for all downstream development. And fourth, confirming our data privacy audit timeline ahead of pilot launch on September 16, 2026. So that concludes our status report. Thank you for your time and attention. We're now happy to open the floor for questions and discussions.